Good evening, protesters. We have another meetup, and this evening we will be talking about blockchain, but not only about blockchain, we will be talking about testing blockchain applications. And who to ask? Do you know any blockchain expert? I'm very happy to say that I know one blockchain expert. It's Sanne. I heard her presentation at Eurostar and it was really perfect. So I'm very happy that she agreed to talk with us this evening. So the floor is yours.
Thank you very much for that wonderful introduction, Lucy. All right, ladies and gentlemen, gentle people, let's begin. I'm going to now share my screen and show you my presentation. Screen 2, there we go, set that up. So today I'm here to talk to you about the challenges with testing blockchain applications. My name is Sanne Visser. I've been testing blockchain quite actively for the past 2 years, interested in blockchain for a bit longer than that. I'll tell you a lovely little story about that in a bit. And today we'll be sticking quite high level in terms of how blockchains work. So some things I will be telling you will be simplified. And other than that, I'm trying to give you some tools that will help you test in early stages of blockchain projects. I personally feel most testers are going to be finding themselves in blockchain projects that are either proof of concept, early days, or just interested and curious about new technology. There's not that many full-blown blockchain projects out there. There are several people working on either cryptocurrency exchanges, and they work with wallets and things like that. So that's the one exception. But I'm generally finding people are entry-level testing blockchain applications. So that's sort of the area I'm going to be focused on. Quite high level thinking as a tester. What specifically about testing a blockchain application is very different from testing anything else. So without further ado, in the beginning. Now this lovely little picture here is one of the only pictures I have left of what was at the time the gaming setup. This is back in 2010 of my husband who decided to play World of Warcraft. And he not only played World of Warcraft, but he played it as a multi-boxer. Now, for those of you who don't know what that is, that's building 6 different computers, gaming computers, having them have these wonderful graphical cards so they could be quick enough, slaving them all together so you can go and be your own guild in the game. So he basically had 6 characters walking around in the game, all run by these 6 PCs that are under the desk there. And this is his setup. Now, I wasn't that complaining about this in the beginning, but as our relationship went on and on, we had more and more discussions about, is this the most productive use of your time? My husband specifically was very interested in going back to college and getting his master's degree. And one of the things that we decided was that, well, maybe then this hobby specifically is not that good for you. At the same time, for any of you that have been really involved in the cryptocurrency, will know that 2010 was the first time that Bitcoin really went up in terms of price. So Bitcoin is a cryptocurrency that runs on a blockchain, the Bitcoin blockchain. And in this year, 2010, it went from about $100 to $1,000 per Bitcoin. These days, it's more around $20,000 per Bitcoin, but those were the numbers back in the day. So we decided, now having these gaming computers that were no longer being gamed on, that we would make a really get-rich-quick scheme. And we would set these 5 PCs into a mining pool. We would mine Bitcoin and we'd make lots and lots and lots of money. So that's what we did. Very quickly, we found out that even back then in 2010, mining Bitcoin as a private person was no longer possible. You needed dedicated machines, these things that use ASICs, and they mine Bitcoin really effectively, and they are mainly what's being used today. And even today, hardware is swapped out every 1 to 2 years to keep up with the mining demands. So we discovered we couldn't do that. So what we did instead is we entered a Litecoin mining pool. Now, Litecoin was an emergent technology at the time. It was meant to improve certain bottlenecks that were there in Bitcoin, namely how quickly transactions could be done. So we set these computers to mining Litecoins. We put a little energy meter in between, so we were measuring quite strictly how much energy they were consuming. And we had this whole setup in our attic. So they were mining there for about 6 or 7 months, and they were on full time. And every now and again, the rewards that we got from the mining pool, they would be going into a Litecoin wallet. We'd be transferring them into Bitcoins. And after about 7 months, we got a knock on the door. So we started sometime midsummer, and then halfway through winter, suddenly the police showed up. It turns out that what they do in the Netherlands quite frequently is they do rooftop scans. And because we were running computers 24/7 and they were giving off a lot of heat, we didn't have as much snow on our roof as our neighbors did. So in this case, you get a very friendly visit from your neighborhood cop. This is typically somebody who's dedicated to your neighborhood for quite a long time. And they came in and asked if they could have a cup of coffee. So of course, we had no idea what this was about. They just showed up and gave them a cup of coffee. And then one of the two cops asked, can I just go and take a quick look upstairs? Of course, it's not a problem. So took him upstairs to the attic. We showed him around. And at some point, he does notice it's quite warm up there, and he asks us, so what's going on? And then we explained about mining the Litecoins, and he gets this big smile on his face, goes back down to his colleague and says, no, this is good. We can leave here. This is fine. And they left. And we were slightly puzzled. They didn't explain the reason for the visit immediately, but after a few days, it clicked that this was one of the things that put our house on the list, because they thought we might have been growing some weed up in the attic, because we had a very high energy bill, much higher than it normally was. We were using less in terms of heating, and of course we had less snow on our roof. So that was an interesting little visit in the middle of our experiment mining Litecoins. Finally, what actually happened is the prices came back down. One of the things about cryptocurrencies is they're highly volatile. And so the price for Litecoin became so low that it was no longer profitable to mine them. So we stopped and we basically sold the PCs, and that's it. We moved on. So this is back in 2010. I still was fascinated by this new technology. To be honest, I didn't understand it at all. And I was quite confused about how everything was done and how everything worked. So fast forward a few years later, and I win the award for thinking of building a blockchain testing framework, Eurostar Rising Star Award 2018. Now, this little prize resulted from a serious deep dive into seeing how I could combine what was still a fascination of mine, these cryptocurrencies, and the work that I was actually doing, which was testing. And I figured there has to be an overlap between the two to make this hobby of mine something more concrete. And it really worked out very well for me. So I've been working on that ever since 2019, basically. I spent the entire year working on blockchain testing frameworks and building different tools and technologies and trying as much as possible to test blockchain projects. So that's the introduction so far, all about me. Blockchain technology is different. It is revolutionary. It does change a lot of things in the way you have to think about things. However, it is not such a thing that it will change completely how you build software. So that's one thing to keep in mind as we go through the rest of this presentation. Now, I want to do a live demo with ethviewer.live. I'll just leave it on the screen there for a bit, and you can go there yourself, because sometimes I know these streaming platforms don't tend to show this website properly. Now, what this is something that is called blockchain television, and it is how I want to give you some of the basics of how a blockchain works. Now, I tested this just before the presentation, and the site wasn't quite behaving itself. So we'll see if we're going to have a bit of a devil demo or whether it's actually going to work. We'll see how it goes. So here's the Ether Live. I'll just try refreshing that and see whether we get a good page. Otherwise, we'll try it another way. All right, at least the transactions are being shown to be flying in here at the bottom. You see these little gray bubbles and you see the little yellow bubbles. And then every now and again, there's going to be little blue ones that are popping up. What those are something that is called a transaction pool. There you go. There's all the little transactions. Now, this is usually showing about 500 transactions in the Ethereum mining pool. Ethereum is a very big blockchain, just like Bitcoin. It's also a cryptocurrency, but it was built in 2016 and optimized for smart contracts, which I'll get into in a little bit. Now, these blue bubbles are smart contracts, and they are showing a smart contract being created. A smart contract is nothing much more than a if this, then that. There's an external trigger, and it then tells the smart contract to do something, which is then paying out basically a certain amount of Ether token and paying for it to be transacted, which is called gas. Now, these blue ones are smart contracts being created, which also costs Ether. The yellow bubbles are contracts being invoked. So there's a trigger that's saying something to the contract, which will make it run. Now, they run autonomously, and then at the end, they will pay out to a few other wallet addresses. And this is how smart contracts essentially show up on the network. All the little gray bubbles are just people transferring Ether to each other, or being traded in trading platforms for cryptocurrency. Now, usually on this website here at the top, there's a bunch of blocks being shown and the links between them. Like I said, I did notice this little devil that's not working today. So I want to show you briefly this. So this is how they represent it usually and how it's usually shown on the television. These little blocks here are then containing some of these bubbles. And it will differ per block how many of these little bubbles that are shown here in the pool are taken out and actually put into one of these blocks. The blocks are then chained together one by one, and each of them will contain these. So if we just look at one of these transactions, let's see. All right, here we go. This is an actual example of one of the transactions. Now, what you'll see is that every transaction will have a unique hash. It'll have a status. It will have which block it has been applied to. Again, here, this website is not quite working, so it's not showing the block that it has been assigned into. It shows you where the transaction came from. It shows you the amount of Ether being transacted, and it shows you what they are paying in terms of gas. So how much transaction fees are being accounted for. So that's there. That's so many Ether. It's also showing here what the current rate is for this system for Ethers. So there's always a translation back into either dollars or euros for most people. So this is a typical transaction. Now, when it's set into a blockchain and you get these forks, hang on, let me get this picture back for you. One of the things that does tend to happen is that you get these two little blocks occurring at the same time. These are called accidental forks. When this little pink block here occurs at the same time as the little yellow block, what has to be determined is which one takes precedence. Now, the way that this happens in the Bitcoin network is one of the two will get dropped, and it will generally be the one for which the least mining work has been done. In the Ethereum network, which is an efficiency improvement, what they actually do is they make one of them an orphan block and they slot it in between and give it a link to the previous one, the one before last, and another link into the next one. And then they secure these what are called uncle blocks into the network anyway. Advantage is you get more transactions processed, you get more speed. So when these transactions in the blocks are all linked together, there's always one chain which is dominant. Now, there is another little thing that are called hard and soft forks. What is shown here is a hard fork where you'll get different cryptocurrencies or different blockchains becoming separate instances because they are splitting up according to the rules that are making the consensus. So going back here, there are rules that will determine how many of these transactions are picked up. There are rules that determine how many blocks will be made every 24 hours. These are all consensus rules in a blockchain. And what happens quite frequently is that developers think they can optimize the blockchain, either improve transaction speed or improve smart contract handling, improve privacy, security, any one of those aspects. And they'll decide to fork a blockchain. What has also been done a lot in the past is that this has been done for profit. So this is why you get the picture that I just showed you. If my screen will just go out of the way there. All right, there we go. So we'll get that in there. This is what happens with Bitcoin Cash. So Bitcoin originally, the chain was forked. It was a hard fork, and Bitcoin Cash became in existence. When this happens, you really literally have two blockchains in existence at the same time, which are still copies of each other. Only once the new consensus software is downloaded onto them, then you start having them being run. All right, last thing, and then we'll switch back to the presentation. Here are the miners. So there's Spark Pool, Ethermin, F2 Pool, and there's a few smaller ones. And you can always see who has mined which blocks. Miners tend to really run data centers filled with these specific mining machines. They cost a lot of electricity. And what they do is they validate networks. They are all over the world, although they're mainly in China, and they basically run a blockchain. And this is what I joined when I set up my Litecoin machines. I joined a pool that was mining Litecoin. These, however, are big businesses and not as small as my 5 little PCs. There is an interesting question for this one, though, because there is such a thing as where if you have all the mining power, theoretically, you could control a blockchain because the miners determine which parts of these transactions are actually put into blocks. So there's an interesting question there to think about, that if this is the case, and as you notice here, you have 23.1% for Ethermin and you have 26.3% for Spark Pool. If these two miners combined powers, you would have more than a 50% stake in a blockchain. And this is where you get something called a 51% attack. If you have more than 51% of a blockchain, you can basically tell it which block to create with which transactions, at which point you control the blockchain and the truth of it, and it loses most of its value, because then how can you trust any of the transactions? Well, that's an interesting question. If this is true, why do these two parties not combine forces? Bitcoin at the moment has a very high value, and they could make a lot of money by just combining their powers and forcing the Ethereum blockchain to do a certain thing. So there's an interesting one for you, and I'll give it away in a minute. Just let you think about that for a second. So the essence of those kinds of attacks is, if you do that, you immediately devalue the entire blockchain. And this is the reason this system stays in place. There's an incentive for these miners in terms of transaction fees and mining rewards to keep in business. It's in nobody's interest to kill a blockchain until, of course, it is. Some of the smaller blockchains are particularly vulnerable to this because they don't have the enormously distributed mining power that the big ones do. All right, switching back to the presentation. So why are blockchains still useful? Well, one of the things that it is it is a trustless system. We don't need people to identify themselves. It's very good at facilitating transactions. It has a very low barrier to entry. I mean, sure, you have to install a little wallet program, but it's quite simple these days to get your actual euros or dollars into these blockchain structures. It's very low cost in terms of transactions, and it has zero downtime. That's another big advantage. The main thing I think is that it's quite tamper-proof, so you don't get that, for instance, maybe your government is not as trustworthy as possibly mine is here in the Netherlands, or you want to have control over your data yourself in terms of things that are privacy sensitive. Maybe you don't want your banking information to be available even to your bank, then these kinds of systems are very useful. It's also really good for tracking things, making unique identifiers and keeping track of them, and showing quite well that they have not been changed. So those are very valuable in supply chains and in insurance kind of use cases. So that's why they're useful. Now, here's an interesting thing about blockchains. Basically, when you start testing, you will find that you will test on your own computer. You will download a blockchain node and you will be your own miner. And in this case, you will test whatever you are testing, smart contracts, application running on a blockchain on your own local PC, and it will not be connected in any way. That's perfectly fine as a beginning. But if you look at the development test and acceptance and production side of things, as soon as you get to test, it gets trickier. There's not really a sort of dev kind of place where you can try things out. You very quickly head into the fact that you need a blockchain simulator. For a lot of blockchains, these are not available. There is some tooling for Ethereum available in the Truffle suite. However, for Bitcoin and several other large blockchains, there's just not much out there. And even if they are simulating them, they're not necessarily as good as you need them to be. There are things that are called testnets. These are basically environments where the developers of the blockchain do test their own code as well. And you can use those as well. And in a testnet, there's no real mining and there's no real gas. So it's perfectly possible to try things out. However, even on a testnet, there's a few catches because it is very much like a blockchain environment. So you do have to watch out for a few things, and I'll get to those in a bit. Finally, you tend to do some testing on the mainnet. At some point, you're going to want to test in production. And there's, for a lot of blockchains, really no way around that, because they either don't have tooling or they don't have testnets. So be aware of that when you're starting out, whether that's something you're going to be facing. Here's an interesting one as well. Costs of testing. Because you are often testing on production, transactions have fees. Gas is not that expensive on most of the public blockchains like Ethereum, like Bitcoin. But as I just told you, it went from $100 to $1,000 and from $1,000 to $10,000. These things do change, and it's quite an interesting feeling to have to go to your manager and explain that you can't complete your tests because they've become too expensive to run. You can no longer do them within budget. And then it has nothing to do with time. It's just that some crazy enthusiast made it a bull market and now the prices have gone up. So be aware that, especially when testing on public blockchains, the prices can be very volatile, possibly making it too expensive to test. Smart contracts. Now, I'm just going to try and be brief about smart contracts because honestly, you could spend an entire day on them. Smart contracts are particularly vulnerable. They are hard to write. Most of the blockchains have their own languages. For instance, Bitcoin blockchain is written entirely in Solidity, and they are tough to write well. They are also often audited or not, depending on the maturity of the little startup that you're dealing with. But here's the main thing about them. Once a smart contract has been installed, it's out there. You install it, that's it. You cannot install a new version. You cannot roll it back. You cannot iterate on that version. Basically, it's out there. It has a kill switch. You can trigger the kill switch, at which point you kill all instances of that smart contract on the network, and then you can relaunch a new smart contract. This is very interesting for us testers because we're so used to now working with these DevOps and Agile and highly iterative processes for software testing. Smart contracts are not that good of an idea to test that way. This is one of those places where you want to test as intensively as you can before you ever get to the stage that you publish this thing. So be very aware when dealing with any kind of smart contract. You want to test the hell out of it before you install it anywhere. Also, smart contracts cost gas. So to initiate them, to run them, and to have them running on a network, you need to design them really well. If you design a smart contract quite poorly, you are unnecessarily paying a lot of fees in transaction fees. So there's also testing for elegance of design, for lightness of use of gas. And that's something to take into consideration. Test data. Anyone who's done anything with test automation knows the value of being able to go back to a specific state in your test data, or to be able to reinsert new data all the time. Blockchains are specifically an append-only system, so there's only ever adding data to the next block. There's no delete, there's no rollback, there's no going to a previous state. So design your test data accordingly. Everything you do is going to build upon the transactions that you have done and build upon those again and build upon those again. So this is a very different way of thinking about test data. It's basically use and dump, and there's very little reuse of test data. Data quality. Again, this is an append-only system. So the other side of that is looking at where your data source is coming from. Almost all blockchain applications at some point will have an interface with the real world. And that's where your data source comes in. When you look at, for instance, a supply chain blockchain, to give a different example, where you are maybe tracking that your oranges are sourced from sustainable farmers who are paid a fair wage, at some point you're going to have to enter data about that sustainable wage, about those oranges and their place of origin into your blockchain. And because you are entering it there and you're not able to delete it, it has to be as right as you can get it. So think about the source of your data. If you're going to, for instance, be using wage payments, for instance, from bank statements from a company, look at that data source. Can it be spoofed? Can we fake this? Can we somehow look at the system and have the data source be made invalid? Is it the right trigger for your smart contract? Do you want to be relying on this kind of trigger all the time? And this is called the Oracle problem. And there's been a lot written about it in the blockchain space. It's worth looking into. It's basically the old database saying rubbish in is rubbish out. Well, with blockchain, it's rubbish in forever. It never leaves your system. So you want to be very careful about what you're using as data sources and entering into your blockchain. All right, then there's an interesting point of maintenance. Now, most of the proof of concepts don't face this in the first instance, but they do face it in the next step. So when you go from having proven your lovely blockchain idea, it works, you've been showing that its value, now you get to the next point and you want to actually build it at scale. And one of the first things that people run into are, it's not going to plug into your legacy ecosystem. Blockchain applications particularly are tricky to adopt into organizations that have a lot of legacy software. It's just not going to scale as well as people might expect. Blockchains are typically quite slow in terms of transaction speeds, and it's going to disappoint your users quite quickly if that's one of the things they're expecting. So be very careful about the ecosystem you're entering your application into. Also, remember, it's not your blockchain if you're using a public blockchain. If it's Bitcoin or Ethereum or any one of these public blockchains that you are programming towards, they are going to do updates. They're going to do soft forks, which will update the Bitcoin mechanisms. Those are there about every quarter, and sometimes they are quite intensive on the developer side because they mean you have to change a lot of your own software to still have your smart contracts run properly. So this is something to take into consideration. Can I manage blockchain updates? How is my integration going to look, for instance, if the price of gas does go up immensely? Think about if you need to switch a blockchain. Maybe you've built it on a blockchain that has now died. There's lots of blockchains that in the past have looked very promising, but have actually turned out not to have enough network effect and have since passed away. And think about your application as well. This is just general maintenance things, but you have to think about all these moving parts in conjunction with each other when you're making a plan to maintain your application. So look at this entire ecosystem. It's very difficult to get people to understand who are not very well versed in blockchain that no, you cannot just manage when they're going to go up a version. You can't tell them to wait, and you can't determine anything about this environment which you're running your software on, because it is distributed and it is international and there is no control over it, which is the whole point. That's what makes it so stable, and that's why there's zero downtime. But it does mean a few sacrifices on a lot of other things. All right, some ethical questions. This is always an interesting aspect, I think, as testers. So we should always be considering some ethics. I have, and these are personal opinions, so you're allowed to have a different opinion. That's perfectly fine. But I think some things don't go together very well. I don't think there should be government blockchains. I'm very much in terms of the freedom side of the blockchain. I don't want to have that type of censorship in any way. And governments really want control over that type of data. So there's quite a few projects going on where there's identification of people on blockchains, where there's certification on blockchains, where they want to, for instance, tie certain government payments into blockchains. And I just think they're all a bad idea because they do give a lot of control out of the hands of the users, which has been the entire point, I think, of all the public blockchains. The whole point has been to give that control and power back to the people that are using the system. So this is a real personal thing, but a real stick that I will keep wielding. I don't think we should be doing this. The other thing I'm seeing coming, and I don't think we can avoid, but I'm very wary of, are the digital and branded currencies. Now, when I'm talking digital currencies, I'm talking about the currencies that the banks are developing. So the European Central Bank, the Dutch Central Bank, all of these large banks are actually investigating and using digital currencies, and almost all of them have a blockchain component. It's enterprise blockchain, so it's not the same as a Bitcoin. So it's fully in control of an institute like this, and it's not anonymous, and it doesn't give you control of your data back. But I do think that's quite worrying. Money should be free, in my opinion, and Bitcoin and Ethereum show that. So that should be there. Even more scary is when you get branded currencies. So you get, for instance, Facebook discussing the Libra last year and trying to launch that. So those are systems where I'm very worried. Because what if we have an Amazon currency on a blockchain and we have a Facebook currency and we can see exactly where all of your money is going? Every transaction will be there. So I'm a bit skeptical of those. I do also see a lot of benefit. I mean, if you're talking about remissions back into your home country, for instance, so like the Nigerian diaspora sending money back, I think they would be massively useful for that. But let's try and stick to public blockchains for those and not a branded Facebook currency such as Libra. The last one I'm going to talk about now, I'm just going to skip AI and blockchain because of the time, is healthcare and blockchains. There's a lot of these centralized patient information systems that are being launched. And there's quite a few of them that are sort of attaching these blockchain components to it to sort of track your medical history. Honestly, this is the type of privacy sensitive information that should never be stored into a type of record that's going to retain information forever. Remember, there's no delete in these systems. So if there's a record on there, it's going to stay there, even if you want it removed. And I just think that's seriously unfair when it comes to healthcare information. There's no need to store them that way. There is still ways to design with blockchain and not store that type of information onto a blockchain if you do still need that tamper-proof evidence for something. But it's very difficult to design properly. And I've seen a lot of projects where I've had some serious doubts. I'll give you one example. There was a group of students that had decided what they were going to do is they were going to reward people for following their doctor's advice. And in this case, it was specifically going to exercise, and doing that consistently would give you points. And the points would then allow you to see your doctor for 20 minutes more at a time. So you would get more intensive healthcare. Now, the first thing that you notice when you look at that is like, that's not that bad. You know, you're encouraging people to be healthy. You're giving them some sort of digital money to reward them for that. And with that money, they can buy the care they want. They can either get some physiotherapy time, they can get more time with their dietitian, and it looks perfectly fine. But here's the ethical issue. If you have people that are struggling to stick to a regime anyway, why are you not giving them the best healthcare to the health professionals anyway? Why are you tying that into some kind of performance point? Because specifically, anyone that's not exercising and not meeting these goals is exactly the person that should be seeing their physiotherapist and their dietitian and their doctor. So why would you incentivize that? And these are the type of questions to keep thinking about with blockchain projects. Ask these questions, drill down into it, because often there's some ethical things that you really want the team to think about. And if they have good answers, that's perfectly fine. Sometimes it does turn out to be very well designed. But that's your role as a tester. You're a question asker. You should be asking these questions as well. So think things through. Some practical examples. I gave this one away. This is the Facebook coin Libra. This is what they call a consortium coin. So Facebook didn't actually own the Libra coin itself. It has kind of failed at the moment. I think it might have a reboot, but they basically asked 100 corporations to sign in and manage the Libra. So they asked everyone to join in and become, as a group, responsible for the maintenance and creation of the Libra blockchain and the currency that would run on it. This way, they would give the idea, at least, that they did not own and control it themselves. So far, they had people that backed the project all pull out. So for now, I think it's on ice, but we'll see where that goes in the next year or so. This one's really popular. Show me your supply chain. There's a lot of examples out there for this. So there's Carrefour, the big supermarket in France. There's here Ahold that have done the oranges example that I gave. There's chocolate. There's tracing the sustainability of fish. Basically anything where there's a real vested interest in showing that it has been fairly and ethically sourced. There's been an interesting blockchain project attached to it as well. Concurrently, there's a lot of insurance blockchain projects in terms of shipping. And this would be, for instance, where you would combine a smart container that has sensors to see whether the container has been handled carefully. So if it has been dropped at too high a speed, automatically the container will tell using IoT sensors and send this data into a blockchain, which then through a smart contract immediately says, oh, this sensor has been broken. That means this insurance smart contract automatically pays out this amount of money to that company, and they automate that side of things. So there's a lot of things going on in supply chains, in ports, in airplane travel. And I think a lot of the airplane projects have also suffered some setbacks this year, but they are still going quite a bit. There's a lot of startup action in that area. Decentralized finance is a whole category, again, you could spend an entire day on. On top of these cryptocurrencies and the trading that has established on that, some really good new finance models have developed as well. So one example is that there's now a corporation which is hosting an exchange, and on this exchange there's a supplier that will sell people agrarian roof space. So if you're a farmer and you have one of these massive barns that you're keeping your cows in, basically you can buy a part of his or her roof. And what you're buying there, of course, is the potential to do something which will make money on that roof. So essentially, I will buy 3% of this farmer's roof that when everyone is in, or at least enough people, that farmer then has enough cash through these investments to buy solar panels or to set up some other kind of solar system. And they will then proceed to put solar panels on, which will increase the value of my 3% of that roof because it now has earning potential, and I will get a part of that revenue back. Excuse me. And one of the interesting things of these types of finance systems is that you can buy very tiny parts of things. So it becomes possible, because a blockchain does allow for things to be cut into very small pieces, to own even 0.05% of a building. And this previously was very difficult to realize, whereas on the blockchain, we can do that very easily. So it becomes possible to, in very small increments, which are interesting for private people like myself, to invest into very big projects. So you can think infrastructure, you can think social incentives, you can make it as big as you want. All you need is a company like these guys who sell you their roof to have the idea and facilitate it on an exchange. So decentralized finance is a really fun area to look into. And then you have the more social projects, the more fun ones. Take a look at this one. Plantoids is the way to Google it. It's a way to create art. It's a way to pay artists for their artwork. And it's a way to have the crowd tell the artist what we want to see. So what happens is the smart contract sets a bunch of parameters. The people in the network vote on them. It could be like, it has to be 2 meters. It has to look like a plant. It has to involve metal or plastics. And then these are entered into a smart contract. The artist sees the money is in reserve, and then they can start building their project. And then when they post the results, that's when the money gets paid out. And this is a self-sustaining piece of artwork that goes on, because then the revenues from that generate the next one and the next one and the next one. So that's just a really cool bit of a more funky example of a blockchain project. Here's my wonderful call to action. I'm still running the blockchain testing community, which I started back in 2018. If you liked any of the things I said, or you're interested in a little bit more, here's a few of the things we are working on. We are looking into building that framework, getting it out there. We do a lot of things for presentations just like this. We have people interested right now specifically in blockchain and gaming and trading in-game items. So there's a presentation coming up quite soon in a meetup. I think it will be December 8th, where there'll be a live demo of an application we build where you can literally take an in-game item that you picked up in one game, you can set it on a marketplace, you can buy it, and then you can use it in another game. So this is a way of sort of getting away from this, if you win this fancy sword or this special gun in your game, you can bring it along and take it with you. So you get sort of a digital property and tradable items across game platforms. It's going to be really cool. So that's on December 8th, I think. I will publish it on my meetup and link you guys all there. So I look forward, if anyone's interested, you know, just shoot me a message or just join up on meetup, and you'll see them coming along. Here's one of the projects that's mine. It's a pet project. I'm going to be presenting on it at Eurostar in a couple of weeks, and it's called the Blockchain Bug Taxonomy. One of the things that I've been doing, I've been looking at all the types of bugs that can occur in blockchain projects, both public blockchains and private blockchains, and I've been trying to classify them into a model. It sort of looks like this. It's changed since then. This was the first version. And one of the interesting things I found is that roughly 20 to 30% of all errors and bugs and defects found in these projects are highly blockchain specific and do require you to know how a blockchain works. The other 60 to 70% are the type of errors we already know. The things we need to look out for that we always do: performance, security. We need to look at whether people are making typos or interpreting requirements correctly. So that's, I think, the most comforting message out of my work for this bug taxonomy. Like 60 to 70% of what you know as a tester is going to translate perfectly well into this blockchain space, and you'll be quite fine. So don't be intimidated by any of it. You'll be fine. And the rest you can figure out, and maybe use my taxonomy to figure it out. That's fine. So we'll get that out there to you. So 17th of November, I'm presenting that at Eurostar. And after that, I'll share the link and you can come and pick it up in the blockchain meetup. So here's an example of that. Smart contracts being highly specific to blockchain, whereas security is a bit of a mix. Some of the things are familiar, like a denial of service attack there at the bottom. But semantic is entirely the area that we already know. It's having an exception not being treated correctly, missing a corner case, having invalid output or input. Those are the things we all know how to deal with. So just to conclude, of course, we never say penny for your thoughts, but Bitcoin for your brains. And at this point, I'm really interested in finding out whether there's any questions. So bring it on. Thank you very much.
Thank you. It was really interesting. I had a bunch of questions, especially about this branded currency, but you already answered it. So thank you for this. The thing with artwork is definitely new for me. I didn't know about this type of using this concept. It's interesting. And I have a question. First question is about your community. Are you doing also online meetups? Because I think that it would be very interesting for us.
Yes, I am doing online meetups. I have calmed down the schedule right now because I'm finding myself having what is very classically now being called Zoom fatigue. I'm online a bit too much. So the schedule's gone down a lot. I used to have them basically every week, which was quite intense. So now I'm back to sort of every 6 week kind of schedule. But I am open to one-on-ones. So at this moment, the group thing is sort of at a bit of a low end, whether the one-on-ones, I would love to intensify those. So go ahead and join the meetup and then just reach out and I'll set up a one-on-one call and we can talk about it for an hour or even 2. That's not a problem. But there's not as many of these big groups at the moment, just in terms of energy. They'll come back, but right now the energy is a little low.
Yes, we know it very well, because at the beginning of the Corona time, it was easier for us to gather. But definitely this is very interesting, and I have another question for you, and this is from our chat. One of our users is asking where should he start with blockchain, because there is a lot of materials about blockchain, and everybody think, yes, we already know everything about it, and then you are in front of, for example, explaining blockchain to somebody and you are like, yes, blocks in chain. So where to start?
Awesome. I think I've listed them here quite nicely. For any general kind of thing, there's wonderful, very free courses on academy.b9lab.com, the top link there. And they are sorted specifically into the different blockchains. So you can very specifically go into, for instance, Ethereum or Corda or Bitcoin or even Hyperledger, some of the enterprise ones, and they are very good e-learnings. They also have paid versions, but the free versions are excellent introductions. They also have a Bitcoin for non-technical people, which is wonderful. So I would recommend that resource to anyone. If you're already quite used to things and you know your way around an IDE and you can follow tutorials, then go to the trufflesuite.com pet shop tutorial. It's good to follow. You can get a lot of help. The community is awesome. This is one of those tool makers I was talking about that simulate blockchains for you. So of course they want you to use their tools, which is partly why they offer this for free, but nonetheless, it's a very good resource to learn how a blockchain works. Finally, there's Rianne Lewis, a very close friend of mine and another blockchain tester. We do share a lot of information together, and she has a wonderful presentation online that she did in the Agile Testing Days in 2019. And she just published a book 3 weeks ago, Finance in the Age of Bitcoin. Wonderful resource if you like the cryptocurrency side of things. And if you are specifically looking into how technically to explain Bitcoin, of course, Mr. Andreas Antonopoulos is the way to go. His book and his website will give you the basics and will let you start very easily. He also has web learnings and really good videos on YouTube to look for. Yeah.
Perfect. So I think that we have things to looking forward. I am interested in this new project about Bugs taxonomy. I think that it will be very interesting. So looking forward to Eurostar presentation and then you sharing with us the link. Thank you very much for this evening. I'm happy something is good in this Corona times that we have more visitors from outside, because now we are we are at the same length, everybody. So thank you and looking forward to meet you again.
Yes, wonderful. Thank you for having me. It's been an absolute blast to do. Thank you.